Imagine standing on the dusty red plains of Mars. You look toward the horizon, but you don't see a mountain, not in the way we think of them anyway. Instead, the ground just seems to slope upward, gently, forever. You wouldn't even realize you were climbing the largest volcano in our entire solar system. This is Olympus Mons. It's so enormous, so mind-bogglingly vast, that its base would stretch far beyond your view. You would have to walk for days and days just to cross from one side to the other. This isn't just a mountain, it's a world-sized feature that dominates an entire region of the Red Planet. Olympus Mons is located in a volcanic region on Mars called the Tharsis Montes. Think of it as Mars's own supervolcano national park. For a long time before we had powerful space probes, astronomers looking through telescopes saw a strange, bright spot on Mars they named Nix Olympica, which means the snows of Olympus. They thought it might be a snowy peak. It wasn't until NASA's Mariner 9 spacecraft arrived at Mars in 1971, we finally saw this feature for what it truly was. Not just a mountain, but a volcano of truly epic proportions. A silent giant that has been waiting for us to discover its incredible story. The sheer scale of Olympus Mons is difficult to wrap your head around. So, just how big is Olympus Mons? Let's put it into perspective with some places we know here on Earth. If you were to take Mount Everest, the tallest mountain on our planet, and place it next to Olympus Mons, it would look like a small hill. Mount Everest and Mauna Loa outlines next to the colossal profile of Olympus Mons. Olympus Mons stands an incredible 13.6 miles, 22 kilometers high. That's nearly 3 times the height of Mount Everest. If you could stand on its summit, you would technically be in the very thin upper layer of the Martian atmosphere, almost at the edge of space. It's so tall that its peak would poke out above the dust storms that sometimes cover the entire planet. Now let's talk about its width. The base of Olympus Mons is about 370 miles, 600 kilometers across. That's roughly the size of the state of Arizona. Imagine a single volcano so wide that it could cover almost an entire state. If you placed it in the United States, it would stretch from Los Angeles to Phoenix. If you put it in Europe, it could cover the entire country of France. This immense footprint is what makes its slopes so gradual. Its summit is marked by a caldera, which is a collection of collapsed craters that is 50 miles. You could fit the entire city of London inside this summit crater with room to spare. Olympus Mons has about 100 times the volume of Earth's largest volcano, Mauna Loa in Hawaii. Why did Olympus Mons get so huge? The answer lies in 2 key differences between Mars and Earth: gravity and plate tectonics. First, Mars is a smaller planet than Earth, so its gravity is much weaker, only about 38% of what we feel here. This lower gravity means mountains can grow much taller before they collapse. On Earth, a volcano can only get so big before it becomes structurally unstable. But on Mars, with less gravity pulling it down, volcanic rock could just keep piling up higher and higher. The second, and perhaps most important reason, is that Mars does not have plate tectonics. On Earth, the crust is broken into giant moving plates. Volcanoes often form at the edges of plates or over hotspots, plumes of magma rising from deep within Earth. As a tectonic plate moves over a stationary hotspot, it creates a chain of volcanoes like the Hawaiian Islands. Earth, plate tectonics creating a chain of smaller volcanoes versus Mars, a single hotspot building one giant volcano. On Mars, the crust is one solid, stationary piece. There are no moving plates, so when a hotspot formed under the Martian crust, it just stayed there. For hundreds of millions, maybe even billions of years, this single spot continuously fed magma to the surface. Layer after layer, flow after flow, it built a single, gigantic volcanic structure. When we search for an earthly comparison to Olympus Mons, we immediately think of Mauna Loa in Hawaii. Mauna Loa is the largest active volcano on our planet. Like Olympus Mons, it is a shield volcano. Measured from its base on the seafloor to its summit, Mauna Loa is actually taller than Mount Everest. It is a true giant, a testament to Earth's geology. Place it side by side with the Martian champion, and the difference in scale is breathtaking. Mauna Loa could fit inside Olympus Mons' footprint. The entire Hawaiian island chain could fit inside Olympus Mons. The volume difference is where it gets astounding. Mauna Loa's volume, approximately 18,000 cubic miles. Olympus Mons' volume, approximately 1 million cubic miles. About 100 times more massive. The Hawaiian Emperor Seamount chain shows plate tectonics at work. The Pacific plate slowly drifts over a hotspot. This creates a trail of volcanoes over millions of years. The oldest to the northwest are dormant and eroded. The youngest, Mauna Loa, Kilauea, active today on the Big Island. The hotspot's energy is spread across many volcanoes over time. On Mars, that energy focused on one spot, letting Olympus Mons hoard volcanic resources. How do we know so much about a volcano millions of miles away? We haven't sent any rovers to climb its slopes. The terrain is just too vast and challenging for our robots. All our knowledge comes from above. We study Olympus Mons with a fleet of orbiters, spacecraft that circle Mars and map its surface in incredible detail. Viking orbiters from the 1970s, Mars Reconnaissance Orbiter, ESA's Mars Express. These orbiters do more than take pretty pictures. They analyze rock composition, they measure height with laser altimeters. By counting small impact craters on lava flows, scientists estimate when the volcano was last active. Fewer craters means a younger surface. Some lava flows on Olympus Mons have very few craters. Scientists think parts may be as young as 25 million years, a blink in geological time. That raises the possibility it might not be completely extinct. Olympus Mons is more than a big mountain. It's a key to unlocking Mars's past. Its existence shows Mars once had a hot interior and geological energy. Every surface feature is a puzzle piece to reconstruct Mars's history. This silent giant beckons us to explore. It reminds us that the solar system holds wonders that defy our earthbound expectations. Olympus Mons symbolizes the grand, epic story of the cosmos, a story we are only beginning to read.